Today we'll be working on the following problem. Let X be a complete metric space. And we have a sequence of continuous function f sub n from x to r, and f from x to r. And f sub n converges to f pointwise on x. So this f is not necessarily continuous, right? So let z in x, we say that the sequence f sub n converges subuniformly at z if the following condition holds, like for all epsilon greater than 0, there exists delta greater than 0 and capital N bigger than 1, such that for any n bigger than capital N and the matrix of y and z is less than delta, implies the absolute value of f sub n of y minus f of y is less than epsilon. So then we want to show that if the sequence f sub n converges subuniformly at z, then f must be continuous at z. So pause the video if you want to work on this problem by yourself. Okay, let's see. So basically, first we recall that converges uniformly, right? So in the converge uniformly for a sequence of f sub n means like for all epsilon greater than 0, we can find some capital N, and then this f sub n of y minus f of y, the absolute value is less than epsilon whenever the n is greater than the capital N. There's no the matrix involved, right? It's uniformly across for all x. So, but here the convergence subuniformly is defined on a point, each point, right? So let's see how to prove this. This is a pretty much a standard epsilon delta proof, right? So we have a sequence of n, and then we have some f, and then at z it's converges subuniformly at this z, so we have some delta. So basically it all boils down, we want to estimate the absolute value of f of y minus f of z for this quantity, right? So the from the definition of converges subuniformly, and then it involves the sequence of fn. So usually we use triangle inequality, we break this into the parts like this: f of y minus f of some fixed m of y, and then plus this f of y minus f y on z, right, of z, and then plus f sub f of z minus f of z. So by triangle inequality. So now we can estimate each term. The goal is to make there as small as possible, less than any given epsilon, right? So from the definition, we can see for all epsilon greater than 0, we can find some delta 1 bigger than 0, and some capital N bigger than 1, such that f sub n of y minus f of y, the absolute value is less than epsilon over 3. Whenever we have the matrix of y and z is less than delta 1, right? This is This is based on the definition of converge subuniformity at Z from this definition, right? So we have this, and then for this n, clearly, if we replace y with a z, so we have this f sub n of z minus f of z, take absolute value, is also less than epsilon over 3, as this, the matrix of z itself is 0. Of course, it's less than dot 1, right? So now, since for this particular, we fix this n, right? So for this fixed capital N, f sub n is continuous by assumption. It's a sequence of continuous functions, right? It's continuous at this z, right? So we can find some delta 2 bigger than 0, such that this f sub n of y minus f sub n of z is less than epsilon over 3 whenever this matrix of y and z less than delta 2, right? Now it's a standard way, like we choose delta to be the minimum of delta 1 and delta 2. And then for this delta, if the matrix of y and z is less than delta, so we have this f of y minus f of z, the absolute value, triangle inequality, right? So from here, now we replace this m with our fixed capital N. This is less than or equal to f of y minus this, and plus f sub n of y minus f sub n of z, and then plus f sub n of z minus f of z, right? Triangle inequality. Now each term from here, this one, because the matrix y of z is less than delta, which is also less or equal than delta 1 and the delta 2, right? So this satisfies this. So we have the first term is less than epsilon over 3. The second term is the second term is less than epsilon over 3 from here, right? And the third term is here, epsilon over 3, which is epsilon. So what we have shown that, for any epsilon greater than 0, we have delta greater than 0. Then if the matrix y and z, matrix of y and z is less than this delta, the absolute value of f of y minus f of z is less than epsilon. So therefore, by definition, f is continuous at z, right? That's it.